Imagine waking up one morning, turning on your compass, and noticing that the needle no longer points north. Imagine waking up one morning, turning on your compass, and noticing that the needle no longer points north. Instead, it slowly spins and settles toward the south. This isn't an optical illusion. It's a sign that Earth's magnetic field is undergoing a massive change. Its direction is reversing. This is not just science fiction. It's a real possibility that has happened before in our planet's history. Earth's magnetic field is generated by the swirling motion of molten iron in its outer core. This flow of liquid metal creates giant electric currents that produce a magnetic shield, protecting Earth from deadly cosmic radiation and solar wind. Without it, the planet's surface would be bombarded with high-energy particles that can damage DNA and disrupt technology. But geological records show that Earth's magnetic field is far from stable. In the past 20 million years, it has flipped direction many times, north becoming south and south becoming north. This phenomenon is called a geomagnetic reversal. The last time it happened was about 780,000 years ago, during what scientists call the Brunswick-Matuyama reversal. If the magnetic field were to change direction today, the process wouldn't be as instant as flipping a switch. Based on evidence from ancient lava flows, a reversal can take thousands of years to complete. However, during the transition, the magnetic field would weaken significantly, possibly to just 10% of its normal strength. This weakening would leave Earth more vulnerable to cosmic radiation. The atmosphere, especially the ozone layer, would become the main line of defense. Unfortunately, ozone can be damaged by high-energy particles, increasing the risk of skin cancer, harming crops, and even affecting plankton in the oceans. The very base of the food chain. The biggest disruptions, however, would likely hit our technology. Navigation systems that rely on magnetic compasses would become unreliable. Migratory animals like birds, sea turtles, and salmon, which use the magnetic field for orientation, could lose their sense of direction. Satellites in low Earth orbit would be exposed to more intense radiation, leading to electronic malfunctions and shortened lifespans. Power grids could also be at risk. Increased solar radiation could trigger stronger geomagnetic storms, inducing massive electric currents in power lines. We've seen a glimpse of this in the Carrington event of 1859, when telegraph wires caught fire due to a solar storm. In a weakened magnetic field, similar events could be far worse, potentially causing continent-wide blackouts. While this might sound apocalyptic, a reversal is not the end of life on Earth. Fossil evidence shows that living organisms have survived past reversals. The difference today is our heavy dependence on technology, which is far more vulnerable to space weather. NASA and ESA scientists constantly monitor Earth's magnetic field, using satellites like SWARM. Data shows that the South Atlantic Anomaly, an area over South America and the Atlantic Ocean, has already been weakening significantly. Some researchers believe this could be an early sign of the next reversal. If such a reversal begins in the next few hundred years, humanity will have time to prepare. We could design satellites with stronger radiation shielding, develop alternative navigation systems based on GPS or astronomy, and build electrical infrastructure more resistant to geomagnetically induced currents. Interestingly, a magnetic reversal could also bring unexpected beauty. The auroras, the northern and southern lights, might appear in tropical regions, creating spectacular skies rarely seen near the equator. Cities that never see the aurora might suddenly experience breathtaking displays of green, red, and purple curtains of light. Some scientists suggest that we might already be in the early stages of a magnetic field shift. The gradual weakening of the field over the past 2 centuries, around 9% in total, could be a precursor to a full reversal. But it's important to remember that a weaker field does not automatically mean a flip is imminent. The field has fluctuated in strength many times without fully reversing. During a reversal, the magnetic poles wouldn't simply swap instantly. Instead, multiple poles could appear across the globe. There could be 4, 6, or even more magnetic north and south points scattered around the planet at the same time. This chaotic magnetic landscape would make navigation incredibly challenging, not just for humans, but for countless animal species. Air travel would need to adapt drastically. Pilots rely not only on GPS, but also on magnetic headings for certain routes and backup systems. If those readings became unstable, flight operations might require new safety protocols, additional training, perhaps entirely different navigation instruments. Another consequence involves radiation exposure for humans, especially at high altitudes. Airline crew and frequent flyers could receive higher doses of cosmic radiation, potentially increasing long-term health risks. Space agencies would also need to revise safety measures for astronauts working on the International Space Station or future Moon and Mars missions. We also cannot overlook the impact on communications. High-frequency radio signals, which bounce off the ionosphere, could be disrupted more often. This would affect emergency services, maritime operations, and military communications, especially in polar regions where the magnetic field is weakest during a reversal. In agriculture, the effects might be indirect, but still significant. Increased ultraviolet radiation due to partial ozone depletion could reduce crop yields and stress livestock. Farmers might have to adopt more UV-resistant crop varieties or invest in protective greenhouse structures to shield plants from excessive solar radiation. The marine environment would also face changes. Some fish species, such as tuna and sharks, are sensitive to Earth's magnetic field. If their navigational cues become unreliable, migration routes and breeding patterns could shift. With ripple effects throughout ocean ecosystems, from a historical perspective, reversals have never been linked to mass extinctions. However, the combination of modern technology, dependence, and environmental stressors could make the next reversal far more disruptive to human civilization than to the natural world. Interestingly, studying past reversals in volcanic rock layers and deep-sea sediments not only teaches us about Earth's inner workings, but also helps us understand other planets. For instance, Mars once had a magnetic field, but it disappeared billions of years ago, leaving the planet exposed to solar wind. Understanding why Earth's field reverses, but doesn't vanish entirely, could provide clues about planetary habitability. Finally, beyond the science and the risks, there's a poetic side to a magnetic reversal. It's a reminder that the Earth is alive, constantly changing, and that even the forces we take for granted, like the invisible field guiding a compass needle, have a dynamic and unpredictable nature. The story of a reversing magnetic field is both a scientific challenge and a humbling lesson in how small we are compared to the forces shaping our world. So, if one day your compass starts pointing the wrong way, don't rush to blame the tool. It might just be that Earth is writing a new chapter in its long history, one about a magnetic pole reversal that will change how we see the world and force us to adapt to the unseen power that has been shielding our planet since the beginning.